do question 7, and the statement reads as follows. A metal sphere X with a charge of 5 nanocoulombs is suspended by an inelastic thread of a negligible mass which is tied to the ceiling at point M. Another sphere Y on an insulated stand has a charge of -8 nanocoulomb and is brought closer to sphere X until their center is 20 millimeters. So the diagram, as you can see here, explains what is written in the statement. So we have sphere X and sphere Y, and this is the thread that ties the sphere X to the ceiling. So this would be a ceiling, right? And this is the distance between both spheres. And going to 7.1 states that we should state Coulomb's law in words. Coulomb's law. So Coulomb's law states that the magnitude of the electrostatic force exerted by charge 1 on charge 2 is directly proportional to the product of the charge. The product of charge 1 and 2 and inversely proportional to the distance, the square distance between them. Right, so now we're gonna do 7.2, which states that calculate the magnitude of the electrostatic force that sphere Y exerts on sphere 2. So we're just gonna calculate the electrostatic force that exists between these two charges, charge of sphere Y and sphere 2. So for us to calculate that electrostatic force, we're going to say use the equation of F is equals to K, Q1 and Q2 divided by R squared, right? And we know that K is equals to 9 times 10 to the power of 9, and then charge 1 is going to be equals to 8 times 10 to the power of -9, and charge 2 is 5 times 10 to the power of -9. Divide by the distance between them, which is 20 millimeters, and we're going to change it into meters, so we're going to multiply by 10 to the power of -3 all squared. So if you notice, I didn't include the sign of the other charge. As you can see here, the charge of Y is -8 nanocoulombs, but you can include it because force has direction, right? You can just include it if you want, and you punch the calculator, you should get 9 times 10 to the power of -9 newtons. So you can, if you include that negative, it's just going to be -9 times 10 to the power of -9. So this sign will just indicate the direction of the force. If you choose right to be positive, then left would be negative. So now we're going to do 7.3, which says that we must draw the resultant electric field pattern produced by sphere X and Y. Right? So we know that the sphere X is positive, right? It's positive 5 nanocoulombs, and the sphere Y, it's negative 8 nanocoulombs, and the movement of charges is from positive to negative. Right now, for us to draw the electric fields, we need to indicate our sphere. So we have sphere X, which is positive, and we have sphere y, which is negative, right? And I said that charges move from positive to negative, right? So we can simply indicate that this one here, the direction of charge, and we'll put another electric field and the direction of charge. So you can simply draw this, which is not really difficult, and another electric field, direction of charge, and then you indicate the rest like this and like that. So this is going to be your electric field showing the charges that are moving from sphere X to sphere Y. Now 7.4 states that sphere Y is now moved closer and makes contact with sphere X, after which sphere X is repelled. So calculate the new charge on sphere X. So what's happening here is this sphere Y is brought closer to sphere X, and when they combine together, they now have the same charges, right? We all know that different charges attract and like charges repel, right? So the movement of these charges will go in that direction and that direction, but these ones will come closer, right? So that's what happened here. So when they combine, when sphere X combines with sphere Y, they will have the same charge and repel after that. So let's do the calculation of this one. So we're gonna have our Q of X new, because we want to know the charge of Qx, the new charge. Obviously both will have the same charge, so it's going to be Q1 plus Q2 divided by 2, right? You all know this formula. And the charge of sphere X is 5 times 10 to the power of minus 9, and then we'll say plus the charge of sphere Y, which is minus 8 times 10 to the power of minus 9, and then we divide by 2, and the answer that you need to get is minus 1.5 times 10 to the power of minus 9 coulombs, right? So this is the charge that is on each sphere. So basically sphere X will have this charge of minus 1.5 times 10 to the power of minus 9 coulombs, and sphere Y will have this same charge of minus 1.5 times 10 to the power of minus 9 coulombs, right? But we are mostly interested in the charge of sphere X.